They're due next Friday, a week from Friday. And also next week is the canned food drive. So I know Mr. Frigie, it's been in my Schoology forever, but I know Mr. Frigie sent an email about it. So look at that. There is one homework problem I want to look at because I set you up for failure. Which one was that?
Number 5 on the back.
On
3.3.
3.3. Okay. So I want to look at this for a second. This is the 3.3 homework, and I want to look at number 5. It is a doable problem, but I have kind of programmed you to, when you look at these big data sets like this, that instead of putting in 1970, maybe you would put in 0. And then for 1980, you would put in 10, and so on, right? We've done that. And then we defined our variable. X was years since 1970. So if we came up with an answer of 12, then the answer would be 1982, right? Know what I'm talking about? Well, here's the problem. When you are doing logarithmic regression, keep in mind, I don't know what your equation would come out, but think of the basic equation. It's going to have numbers and stuff in it, but this is the format of the equation. Can x be 0 in this setup? No, it can't. Because, think about your logarithmic curve. Isn't there an asymptote at 0? So, when you rewrite these points, and you're allowed to rewrite them any way you want, but when you rewrite them, you're not going to be able to use a 0 here, because in a logarithmic equation, x can't be 0. So, this was brought to my attention because somebody, was it you? She came in and said, hey, I'm doing everything right, but my calculator keeps saying error or something. Well, it was because she was trying to put a 0 into a logarithmic setup, and you can't do that. So, caution. If you had that same problem, go back and redefine your points. You can use 1970, 1980, 1990. You can actually use those numbers if you want. There's nothing wrong with doing that. Graphically, it's kind of a pain in the butt, but you're not graphing this, so it's okay. Huh? Logarithmic regression. We talked about that yesterday.
Is that LN
Yeah.
graph?
Uh-huh.
I get like
And that's okay. That's okay. That's all right. Yep. I got a huge number too. When I
So everyone else got like a really, really big number?
Uh-huh.
Yeah.
Yep. Yep. So did I. So did I.
2005, like 4. I never even turned it in, but.
The answer is sometime between 2024 and 2025.
Yeah.
But the equation has massive numbers in it.
Yeah. And it was even bigger when I did the 70. Like it would have fit on the line.
Cool. Wasn't that exciting? Okay. All right, so I wanted to talk about that one. I think there's one more. We'll talk about that. We'll do a homework catch-up day. Start keeping track of homework questions. We'll do a homework catch-up day. I want to get a few of these equations done so that we can review a bit after lunch for our quiz that we're taking tomorrow over 3.1 to 3.4. But I do have a review sheet here for you, so don't panic. All right. Did it yesterday. All right, 3.5. We're on 3.5 now, and we're ready for 1E. We need to solve a few equations today. So open your mind. Put the moon out of mind right now. We are focusing on our logarithmic and exponential type equations. All right. So
rewrite this?
Any ideas how we start this problem?
They don't need to be
Put the 3 to the 2, so it's 2 to the 3rd.
So she says, let's take care of this and make this basically ln8, 2 to the 3rd. That's one of your properties. A coefficient on a logarithm is really an exponent. Perfect. What about this other side over here? What's going on over here? See a logarithm plus a logarithm? What does that mean? They've been multiplied. So this is ln x minus 3, x plus 4. Got it?
Wait, where's the 8?
What's 2 cubed?
Oh, okay.
Exponent. Coefficients and exponent.
Can we factor that?
Now, well, it's already factored. You need foil it?
Yeah.
You can absolutely foil it, but I want to call your attention to something. This says ln this equals ln this. So in other words, the logarithm of this is the same as the logarithm of this. What does that mean about what's in my hands? They gotta be the same, don't they? They gotta be the same. So I can go from here to here. As long as I've got one logarithm on both sides, doesn't it just make sense to you that if ln x equals ln y, then x and y have to be the same thing?
Is that just dividing by ln?
No, no, no. You're not doing any operation. You're dropping them out. There's no division. ln is not a number. ln is just a symbol for something. We're saying that if ln x is the same as ln y, if those are equal, then x equals y. Now, notice, I didn't do that in the very beginning. Because that only works if it's log equals log. You can't have 2 logarithms over here. You can't have numbers out in front. You have to rewrite it so it's log equals log. Then you can set the 2 things equal to each other. Now I would definitely FOIL. We're gonna subtract the 8 over. That factors. So I got -5 and +4, if I did that right. Double check that. Is that look right? All right, now, be careful. Because if you go back to your beginning equation, very beginning, and you put in -5, what's going to happen right here? You're taking the logarithm of a negative. Look at your picture. Can you take logarithms of negative numbers? No. So that's an extraneous root. Now, I want you to really get this. That number is not extraneous because it's negative. That number is extraneous because when I plug it into the equation, it makes this negative. So if that had been x plus 6, then there's nothing wrong with -5. You see what I'm saying? So don't just randomly cross off negative answers. Sometimes positive numbers don't work. Now, 4 does, 4 is fine. But what if this had been x minus 8? Would 4 be okay? No. So always, to determine if you're extraneous, go back and plug it into the original problem. If this turns out negative, then pinch it. Okay? All right. What about F? What? Ooh, I wrote caution there. What is, oh, so somebody said make it 2 log x. Can we do that? We absolutely can do that. We can write that as 2 log x equals 2. Because When you take the logarithm of something to a power, you can pull the power off. Okay? Now what?
You divide by 2.
You can divide by 2. These are just numbers. You can divide by 2. So log x equals 1.
1. 10 to the 1.
So the base on that is understood to be 10. So 10 to the first equals x, so x equals 10. Why did I write caution there?
Go back plus or minus.
Exactly. Now, if you do the problem this way, which is fine, there's nothing wrong with it, but if you do it this way, you get one answer, right? What if we go back to the beginning and say 10 squared equals x squared? Could we do that from the very beginning? Yep. And then what happens? X equals plus or minus 10. Now, can x, go back to the original problem, can x be a negative 10? Yeah, because you are squaring it. Yeah, you are squaring it. And when you check your answer, you want to check it in the original problem.
What's the property with the base you did? 10? How do you do that?
This,
Yeah.
oh, you need to know, that the log base b of x equals y, that's the same as b to the y equals x. That's how we rewrite logarithmic equations. That's a property. You gotta know that. Mr. Miller called it log rolling. What do you want to call it, but you gotta know it.
So, why doesn't it work with the plus or minus 10?
It does,
On the different way, like
well, because you lost your square.
yeah.
How do you get two answers from a problem? It's gotta be a quadratic, right? As soon as you take away the quadratic aspect, then it's no longer, you're not no longer gonna get that second answer. So if you recognize, after you go through this work, if you say, but wait a minute, it could be negative 10 also, that's okay, as long as you realize there's both of those in there.
So you have to have both plus or minus 10?
Yep.
Okay, because you just have to be able to recognize it when you do like the original.
Yes, yes,
Okay.
yeah, which I think is what she did, I'm not sure, but I think she just recognized.
Back on the one we did before, I feel like I'm missing something, like why can you just, like if you're adding the natural log of x minus 3 to the natural log of x plus 4, why are you, like, I don't know how to say it, like, how does that work that you can like multiply
Okay.
those together?
There are properties of logarithms that you are absolutely responsible for knowing. And one of the properties of logarithms says that the logarithm of a product is the sum of the logs. We did it yesterday, did a whole bunch of examples of it. And then it works both ways. It's a property, so it works both ways. When logarithms are added, it means the numbers have been multiplied. When the numbers are multiplied, you can separate it. We called that expanding yesterday. And here I forget what I called it, but we put them together. Okay? Remember, Maren? We did a bunch of them yesterday. Same thing. All right. Problem G. This is a doozy. Alright, this is a easy woozy. So tell me what you think. Maybe I don't even know how to start. What should I do to get started?
Can we multiply by 3?
Oh, is it the 2 on the bottom?
I go on the wrong side. We're still on the. No, you.
We're still on G. You skipped ahead. So clear the fraction. So Chris says he thinks maybe this would be a good idea. I think so too. Get rid of that fraction. You got a thought, Sam? Throw it out.
No, well, I was gonna say, you could do the thing where you reduce the 12, but you can't do that you can't get it to
It's not gonna be a power of 2, no. So his thought was, these are 2s, I'll make this a 2. Like if that were an 8, I could make it a 2 cubed, or 16, 2 to the 4th, but I can't really do that with 12. So that's a good thought, but I can't do it. Emma?
Are you able to add the exponents because the bases are the same?
You can only add the exponents if the numbers have been multiplied. Yeah. So if this were this, then I definitely would do that, okay? But it's not.
Do the numbers divide?
Change 2 to the negative x into its fraction form.
Okay, so 2 to the x minus 1 over 2 to the x equals 12. Now, you might be thinking that makes it worse, but no, we're on the path. That's a good idea. Get rid of that negative exponent.
Can you multiply
Perfect.
by
Now, Tess? Remember, you have to talk loud. Huh?
Get a common denominator?
So in other words, what you're saying is, let's just ditch the denominator. Let's multiply everything by 2 to the x, and then that won't be a fraction anymore. So if I multiply everything by 2 to the x, I'm gonna have 2 to the x times 2 to the x minus 1 equals 12 times 2 to the x. Everybody see what she said? Perfect. What's another way of writing that? Now, Emma, these are being multiplied. So now I can add those. So this is 2 to the 2x minus 12 times 2 to the x minus 1. I'm just going to go ahead and get 0 because that's what I normally do when I'm solving equations.
Do not times it out.
Huh?
Do not times out the 12 and 2x.
You cannot multiply these together because that one has an exponent and this one doesn't. So these are going to stay separate. I'd like you to think about this for a second. I wrote it as 2 times 2 to the x, but could I have written it this way? Would that be the same thing?
I think, yes.
What happens to those exponents? They get multiplied? Isn't x times 2, 2x?
Would you not distribute it?
Right, but what, yeah.
Yeah, well, my question, Maren, was, is that okay to rewrite that way?
Could you write it as
No.
4?
Okay, Maren, why not?
Because wouldn't the 2 get distributed to the 2 inside the parentheses?
No. When you have 2 exponents, when you have x to the m to the n, what do you do with those exponents?
Multiply them.
It does not change the base. The base doesn't change. Now, if you wanted to write this as 2 squared to the x, that would be 4 to the x, but that will not serve my purposes because I need everything to be the same. Okay? Alright? So here's what I want you to do, and anybody else she's courageous enough to ask. You need to put these properties of exponents and logarithms on note cards, and you gotta hammer them in. Okay? Hammer them in. Because properties are properties, and there's no discussion. Okay. So I'm gonna choose, I could do this a couple different ways, but I choose to write it this way. Now, what I'd like you to think about for a minute is this. That is a very ugly equation. But isn't it basically, pick a letter, I'm using M, minus 12n minus 1. Now look at that. Isn't what I have written here the same as something squared minus 12 of those things minus 1?
Yeah. Quadratic.
Exactly, it's a quadratic. The something is 2 to the x, but it's really confusing for me when I look at it like that. It's something, call it whatever you want. In calculus, we use u a lot, call it u substitution. So u squared minus 12 of those u's minus 1. Now, when I write it that way with m's or u's or x's or something, that's a solvable, right? I could solve that. what would I do to solve that?
Quadratic.
I would, it doesn't factor, so I would
Quadratic
probably
equation.
use the formula. So m equals, if it factored, I would factor it for sure. M equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's get a couple of decimals, and let's go about 4 decimal places. So, what's that? Is that 148? So 12 plus the square root of 148 equals divided by 2. I got 12.0828 if I go with 4 decimal places. 12 minus the square root of 148 divided by 2. And I got negative 0.0828 for my other one. Is everybody still with me here? Just use the quadratic formula. I technically got 12 plus the square root of 148 over 2 and 12 minus the square root of 148 over 2. But I thought it might be easier if we had decimals in front of us. Now, this is not the answer to the question. Those are my m values. But what did I let m stand for?
2 to the x.
2 to the x. So 2 to the x equals 12.0828, or 2 to the x equals negative 0.0828. Does that make sense to you? We had a problem that was something squared minus 12 times something minus 1. So we solved for the something. We called it m, and we solved for it. But m replaced 2 to the x. So 2 to the x is these two things. Now this one I'm going to throw out, because is it possible to raise 2 to a number or power and get a negative? No, so that's no good. How am I going to solve this one?
2 to what power is equal
I'm
to?
gonna take the logarithm of both sides, right? I told you, this problem is a doozy. And as Peter has pointed out, there's another one. All right, so here we go. Erase this now, here we go.
Do you need to log both sides?
So x, yes, you have to log both sides. You cannot log one side. It's like an equation. Whatever you do to one side, you do to the other. So isn't x gonna be that logarithm divided by this logarithm? So log. I got 3.59. So just for fun, let's see, we have some round off error, but I want to show you this works. So you take your 3.59 number, raise 2 to that power, so 2 raised to the 3.59 minus 2 raised to the negative 3.59 equals divided by 3. What'd you get? Just about 4. Yeah. We have round off error, so it's not perfect, but yep. You should feel very accomplished. Let's try the next one. Now that we've been through one, this next one shouldn't be as hard.
Wait, watch the side button. Like, go.
All right, so think back, take a look at the problem. What might be a good way to get started? Multiply both sides by 2. All right, what do we do after that? Generally speaking, of exponents are not our friends. We do need them in scientific notation, but other than that, we don't like negative exponents. So we'll rewrite that as 1 over e to the x. And then we're gonna get rid of that fraction, so we're gonna have e to the x times e to the x plus 1 equals 8 e to the x. And here comes the part where you gotta be a little sophisticated. You have to recognize that this is e to the x squared, because it's e to the x twice, minus 8e to the x plus 1. So e to the x times e to the x is e to the 2x, exponents added. 2 times x is the same as x times 2. So that's e to the x times 2. Exponent times 2. So, do you recognize quadratic form right here? Something squared minus 8 of those things plus 1. So, m squared minus 8 of those m's was a plus 1. Which is a solvable equation. For my m, or whatever letter you use, values, I got 7.8730 and 0.1270. But are those the answers to the question? No. Those are m values. That's my phone. I'm not sure. I've been getting tons of spam. I keep blocking them and they just keep coming. We let m be e to the x, didn't we? Isn't that what we substituted in? So that means e to the x equals 7.8730, or e to the x equals 0.1270. Now we'll ln both sides. And what happens over here? ln e. So x is going to be ln 7.8730, so 2.06, or ln 0.1270, negative, you get the same thing, only negative?
Yeah.
Okay, that's interesting. Okay? All right, let me give you your review sheet. And now, this review sheet for the quiz tomorrow is this front page. But in my quest to save paper, I did the whole chapter review sheet and test day is also here. But the quiz tomorrow is only the front side. So when we come back from lunch, I will just randomly pick problems unless you find some during lunch that you want to do. Okay? We're not gonna do the whole sheet, we don't have time. The answers are online. So you can do the whole sheet online. But I will do after lunch, I will do whatever one you pick, or I will. Okay? So we're at lunch and we're back at 50. Is that right? 50? Is that when we just come back?
That?
That would be one.
Uh-huh.
That's hilarious.